Welcome, everyone. I'm Katrien. I won't be doing much here today. I'm just here as the person leading the communications for EOSC Future to set everything in motion, and then I'll give the floor to our speakers. Over the past few months, we've been organizing sessions where speakers from different EOSC projects have presented solutions for mid to long-term data storage that are available through EOSC. And then last month, we also had an overview of different software solutions. Maybe you were already there for these sessions. If you weren't, you can still rewatch them online. If you want to send them to something else as well, you'll find all the recordings on the EOSC Future website and also on the EOSC Portal YouTube channel. So EOSC Portal has a YouTube channel, and you'll find all recordings there, including this one, let's say day after tomorrow. Today, we have a new topic for an Ask Me Anything session, which this month is compute. So we're having a look at different compute resources that are available through EOSC, how they are classified, how you can use them, how they can be onboarded, and a use case for them as well. A note on questions before we get started with the session proper, which is that we'll be collecting questions through Slido. So rather than posting messages in the chat where it's very easy to lose track of what people are saying, we have set up a Slido where you can post questions and feedback. You can also upvote the messages that other people post there so that we know what you as a group think is most important. And then at the end of the session, there'll be time for a Q&A where we go through these questions and speakers will get you some answers to them. Then there's nothing left for me to do but to introduce today's speakers. So with us today, we have Gergely Sipios, who is the Head of Services, Solutions and Support at the EGI Foundation and the Technical Coordinator of the EGI ACE project. He will first give an overview of the compute services available in EOSC. Then we have Eleonora Testa, who's a Senior R&D Engineer, also at the EGI Foundation, and a colleague of mine on the EOSC Future project. She will give more information about these compute resources, how they can be accessed and how they can be used. And she will also give a quick overview of ways of onboarding resources. And then finally, we have Miklos Ban, who is a biologist at the University of Debrecen, who will be presenting Open Biomaps, which is a compute resource, and he'll tell you more about his experiences with the computational capabilities of EOSC. So without further ado, Gergely, the floor is yours.
Thank you very much, Katrien, for the kind introduction, and welcome everyone to this webinar, which will focus on the compute services that are available in EOSC. So let me jump in to the overview section. And let me start with a snapshot of the EOSC portal, which is the landing page if you want to interact with EOSC services and resources. This screenshot shows you how you can reach the compute capabilities through the EOSC portal. There are two ways for doing this. One is to go to the top level and click on the services and resources and then select access to physical and the infrastructures. Or the other option is that below there are two options, scientific domains or generic categories. You click on the generic categories, and also there you can find the access to physical and the infrastructures. No matter which route you follow, you will redirect it to the marketplace section of the EOSC portal. Through this marketplace, you can interact with the offered services and capabilities. You can find detailed information about them. Because you clicked on the e-infrastructure section, access to physical and e-infrastructures, you will be immediately taken to this view where you can see that this category is already opened, and there are several subcategories under this: compute, data storage, instruments, equipment, material storage, and networks. Today, we will focus on the compute capabilities. You can see that there are 49 entries in this one. So if you click on that one, then you get into an even deeper level, which shows a kind of categorization or classification into sub-type of compute services: container management, job execution, orchestration, serverless application, virtual machine management, workload management, and other. Through this, you can you reach actually the bottom level of this hierarchical classification inside the EOSC Marketplace. And by choosing any category, you will get the views of those entries that are classified into that given group. What I'm trying to do next is to kind of translate for you what's the difference between these different subcategories. Here I just pulled out the same list that you saw on the previous slide, and you can see how many entries are in the different classes. With my knowledge on computing, through the EGIA's project that I technically coordinate and through the history of offering compute capabilities, I personally found this categorization on one hand good, but on the other hand not so much matching the kind of historical and the current terminologies that are used in computing. So I rather draw on the right side a kind of mapping of how I would explain these categories for you. So there are fundamentally two types of services inside the compute category. There are what I would call infrastructure services inside the infrastructure layer. And in this one, there are four types of entries: high performance computing systems, or often called supercomputers; high throughput computing systems, also very often called or referred to as clusters; virtual machine management, which in the traditional naming is often called cloud services or public clouds or academic clouds; and container management systems. And on top of that, there are different types of what I would call platform services. These lend themselves more to the workload management, to the orchestrators, or sometimes to workflow systems that are available within the subcategorization. These platform layer services are typically offering something more than just baseline computing infrastructure and baseline computing capabilities. There are, for example, tuned or compatible with a specific type of baseline infrastructure computing, or they offer more advanced kind of job management or management of multiple jobs together, or management of a set of virtual machine images together, or a set of containers together. So these platform layer services, which are mostly foundable in the other categories and spread in the workload management, are, I would say, another layer of the entries that you can see in the compute category. And together, these infrastructure and platform layers are still, I would say, relatively low-level service capabilities. So typically, they are requested by a scientific project or an individual user or a research team in order to tap into some compute capacity for their own application or their own data processing purposes. So they need to integrate their own applications, need to integrate their own data sets with those machines. So the question then boils down of, if you are such a user or user project or scientific experiment, which type of compute service you should tap into. And on this slide, I try to put together these four fundamental infrastructure type of computing capabilities and compare them a little bit from the typical user perspective. So the high performance computing systems is what often called as supercomputers. These are typically used or suitable for scientific problems that can be kind of translated into a set of strongly interconnected processes that need to communicate during the execution of a computational task in order to resolve a single simulation. Are very easily or kind of naturally translate to high performance computing architectures. The second group are high throughput computing systems. These are most suited to computational problems that can be broken into many independent tasks, where these independent tasks or jobs can be sent to different processing sites or different processing computer CPUs or GPUs. The final results can be merged together by a single processing unit into a bigger final result. So they are typically used for parameter sweeping type applications. These are, or simulation of particles that are working independently or existing independently from each other. So for example, high energy physics, astrophysics, astronomy is using a lot of high throughput compute systems. The third category are virtual machine management. So these are the, I would say, the traditional cloud systems where a scientific application can be lifted and shifted in the form of a virtual machine image onto this external infrastructure, and it can be operated either as a standalone service, for example, a web server to serve a community, or itself can perform some computational tasks inside the virtual machine environment. So these virtual machine providers are typically used for long-running servers. Many web applications or virtual research environments are operated in the form of a virtual machine system, a virtual machine on cloud computing platforms, or are also suitable for applications that have very specific operation system requirements or kernel requirements that are not satisfied or offered by the ready-to-use high-performance computing or high-throughput computing systems. And container management is, I would say, the youngest out of these four systems. These are very much trending solutions, an even more lightweight version of virtual machines, if I may say that. They enable a quick deployment and portability of applications from laptops to larger systems, and are suitable for very similar application cases than virtual machine management or the virtual machines, but are even more lightweight, smaller size application or smaller size containers that needs to be transported. So in the last column, the last row of this table, I just give you some further hints of what are the pros and cons of choosing one model over the other. The high performance and high throughput systems are very similar in a sense that they both offer a job management and job distribution platform for you. So what you interface with is an API or a command line interface through which you can define your computational jobs. You submit those jobs, and then the system itself will take care of the execution, the monitoring, and then spitting back the results for you. It's a higher level abstraction because the whole job management lifecycle is taken care of by the systems, or more specifically by the middleware, which is operated on those systems. The difference is what I said earlier, that with high throughput computing, you have many independent calculations. Typically with high performance computing, you typically have a strong interconnection between the CPUs. Therefore, it's much more suitable for applications that require frequent communication during execution time. The high performance computing systems on general can be a scarcer resource. There are less supercomputers all around the world than high throughput computing systems. So typically there is a peer review process to access high performance computing systems. Meanwhile, it's more easy to get access to high throughput computing systems on average. The virtual machine systems allow you complete control of your resources, but at the same time, it may cause more complexity for you. You need to manage resources, scale up or down the CPU numbers or memory that your application or your operational environment needs. The container management system is emerging as standard. There are things like Kubernetes, you may have heard about that, which is taken up, I would say, quite rapidly inside the academic research environment. There are related standards for the management of multiple containers. So even the clusters of containers are now managed through these systems. However, the disadvantage is that you are facing with yet another technology which can cause a steeper learning curve at the beginning, even though at the end it may pay off. So hopefully with this small explanation, you can choose the right system. And as a summary, basically from the left to right, in the left side, we have a higher level abstraction offered by the computing systems. In the right side, it offers more flexibility and configurability for you, but it comes with a higher responsibility on the user side as well. So let me hand over from here to Eleonora, who will continue with how to access these resources or how to provide compute resources if you are interested to join EOSC as a provider.
Thank you, Gergali. I would like just to add a little thing to my introduction because I'm not only a member of EGI and working in EOS Future, but I'm also a member of the EPOD team, that is the EOS Portal onboarding team. That's why I also had the opportunity to speak with many providers and to try to understand from their point of view, which is the best thing when they onboard the services, which are the main questions, which are the main topics that we discuss almost every day to support them in the proper way. But now let's start from users. Why a user should log in and find something here in the portal. I would like also to show you the portal in a minute now, just to see a little summary in a couple of slides. So obviously you need an authentication before accessing the portal. There are many two-factor authentication systems. You can also log in with your seed credentials. And after that, you can select in the marketplace that also Gergali showed at the beginning, your services. You can search it by name of the service, category, project, or even provider. In the main page of the service, you can find all the information you need. I would like also to highlight that we have 4 different kinds of categories for what's concerned to request a service. This is why, that you can see on the right side of my slide, fully open access, order required, and other order type. What does it mean? It means that the portal would like to offer the maximum flexibility to all the providers. We have big providers, big companies, big organizations, big federations like EGI that host more than 200 providers, but also very small providers, very small developers like company made by 2 people. So we want really to be sure that it's possible for a user to find the service that they need, not to have any kind of complexity for what concerns the access that they want to request, in the sense that there is a lot, really a lot, that is fully open access, data, services, software, and so on. The open access, as you can see, just require authentication, but the mechanism is absolutely similar to the fully open access. And when we speak about order required, is generally for bigger organization in which there is also a kind of integration for which from this page you can reach the provider by an automatic mail or a ticket that is generated in their ordering system. This is not, can I say, a complexity in terms of the communication, because in any case, the user then will speak with the provider directly and to agree about what they really need. Where order is required, typically is also define a pricing system. But once again, it depends on the final agreement that you achieve with the provider. And then there is other order type, because as I said before, also for small organizations, very small providers that don't have maybe complicated ordering systems, it's possible to discuss directly with them how to use their services. And once again, the EOS portal would like really to host any kind of provider and to offer to any kind of user the opportunity to access the service in the easier way. So let's go to the second slide that I will show you the portal. For what concerns the providers, and then I will show you a typical template for onboarding a service, the provider that, as I said before, are really of any kind of. So it's possible to join under an organization, under a federation, or as a single provider, or both. That is, one of these registration doesn't exclude the fact that you can be as one of the provider of service in an organization or a single provider. So also from this point of view, you can really, you are free to onboard your services as you like, as you prefer, and as you need, in the sense that, as I just wrote up below, big organizations obviously are, can I say, can help for what concern the interoperability, the fact that they can participate to many projects, that they have the same kind of service management system, and they have a lot of trainings, maybe already a website and ready documentation and policies and similar things. So be part of an organization sometimes seems easier for a provider to have all this information ready through the organization. But also a single provider can have the advantage, we are not speaking about the dimension of the provider, any kind of, because of it is more flexible. If they want to change something, they don't have to change the things at the level of an organization, but just at the level of the single provider. And on top of that, they could have more visibility at local level. There are a lot of projects that at the moment has a focus on the at country level and national funding opportunities. So also to have the possibility to be part of big organization or single offering as a provider is something that can help a lot both parties, the providers offering the services and the users that want to find something maybe also at local level. Considering I would like also to highlight that the portal is under big improvements. There were more than one project in EOSC that started also last year to improve the template, to can I say suggest some standards that can help to have a common quality of the services, a common quality of the access and similar things. EOSC Future is now another project that is really working in many work packages actively to create something that can solve any problems that existed in the past, but also that can achieve a full customer satisfaction, if I can call it in this way, from the user perspective. There are a lot of task forces that are developing policies, working procedures and processes and so on. And for sure, we will see new release of the portal in the next months. So if I can share a minute my screen, I would like to show you the portal. May I? Thank you. So, as we said before, you can search in the catalog and marketplace the service that you would like to use. Here is a typical example, cloud compute, because it's also the topic of this Ask Me Anything. And you can see that here we have EGI Foundation as an organization, but all these providers can offer the same service, as we said before. How to access the service? Sorry, I would like to minimize it. Okay. Here is a case of order required. So you just click here and go to the offer. The interesting thing is just that selecting the offer, the provider has to set up this kind of parameters. Selecting this offer, then, as I said before, the provider receives, in this case, an email, and then you can start your agreement with the provider in terms of what you need, how you need, and so how to access it, and so on. But I would like also to share with you something related to sorry. No, I would like to show you exactly the dashboard, the one that is used by the providers. Now it asks me again, sorry, to log in, but I was logged in, so this is, come on. Okay, so for providers, you come here and you start your registration, become a provider, and then registering your service. But I would like to show you from my ePOT credential how a resource template should be, which are the information that you need because of, as I said before, the registration is not that complicated, but it requests a minimum attention to prepare the information needed in advance. Because of one of the things that we notice, sorry, I'm looking for my EGR thing. If you go, can I say, up and down, for any reason you want to go back, and some errors start to generate, this is a software that can suffer a bit about this activity. But if you go through each record one time and prepare the information that is needed, that, believe me, is a very easy one, then you can onboard register your service in 10 minutes. For example, I would like to show you that everything that has an asterisk like this means that they are mandatory fields. As an input, sometimes we found that the provider, for any kind of reason, don't fill up these records, all these records. And in that case, the registration cannot be approved. So it's important to add all the information that are related to a mandatory field, but we also strongly suggest to add something more that can help the user to understand who you are, in which funding area you are, in under which project you are working, because it's really easier for them to find you. I would like also to say something about this management record, in which there is the help desk, there is the user manual. I think that from the user perspective is extremely important, even if it's not mandatory. If you have one, please add it or link it. Terms of use is another thing that it's important from the user perspective, and privacy policy, it's another important area because of the EOSC Future, who is working in developing the portal, would like really to be sure that we are GDPR compliant. So these two records will become mandatory in June, because this is really a picture of the improvement that step by step we are achieving, because it's really important, as I said before, to have the same standards, the same quality, but also the same regulation for what concerns the privacy and the data that are presented here. So marketing is not so horrible, it's just the description of the services. And it's called marketing because of, once again, it's better not to be too technical in this description, but to help any kind of user, even a person that maybe is not the final user, but is looking for something for the student, for any kind of, to have a general description that can explain clearly the functionality, but not exactly all the technical things. You will have any possibility to discuss with the user all the details. This is why the contacts are fundamental. Contacts and public contacts, because in the portal, this will be the visible one. Please make sure that the contacts are filled up properly and it's possible to contact the provider easily. Sorry, I would like to stay here half an hour to discuss this and show it to you, but my time is over. So if you have any question, contact me. Unfortunately, I cannot stay for the Q&A because I have to join back a workshop in which I was before, but I was really happy to be here today. Thank you.
Thank you. Let's continue with Miklos, who will give us a user example about how he interacted with some of the compute services from EOSC.
Yeah, thank you. Thank you very much. In the following, I will show how we are trying to build additional virtual layers on top of the computational capacity provided by EOSC in order to simplify the analysis of conservation research. The Open Biomaps was originally created to provide IT support for conservational work in national parks. So we developed databases and data management tools for national parks, and these developments have rapidly improved the quality and usability of data. Better data management, better data quality, and more accessible data have also had an impact on data collection for research purposes. And in the meantime, so it started this project 10 years ago. This was the first 5 years. And in the meantime, research projects have started to join Open Biomaps and influence the development of the system. And the new tools that have been developed for them, for the researchers, have improved the toolbox of the national parks data collection as well. And now we are focusing on research and conservation together. We're trying to bring research tools directly to national parks, and we are trying to give researchers more advanced tools with a particular focus on helping them work together on biodiversity data. This is one most important aim of the Open Biomaps, to connect people, the researchers and conservationists to work together. So this focusing has been started approximately 3 years ago, and this was the moment when we met EOSC. When we were beyond supporting data collection and data creation, and we're looking for a way to support analysis. We can go ahead, please. Yes, so it's look good to have a large computational capacity, which is necessary because ecological analysis for conservation typically include many variables and large number of degrees of freedom, which makes the analysis of relatively short data sets extremely CPU intensive, even using well-optimized methods such as XGBoost, but much worse if you're using random forest or other methods. So we need lots of CPU to perform these analysis. So our first plan to create persistent computation server service solution based on an EOSC capacity has failed. There is a trade-off between the time availability of service and this computational power. So the high computational capacity typically is available only for a short time, but we wanted to create a permanent service. So this was a bad idea. Could you please go ahead? Thank you. So we changed the plan to create a dynamic computational service using a new Open Biomaps computational layer. So we implemented a new layer and another new layer. Could you please go ahead? Yes, this is a bit complex figure about how it looks like. So we have lots of Open Biomaps servers, currently maybe 10 or more, I don't know exactly. And the Open Biomaps servers, there are several projects. So there are some servers where there is few national parks or research groups, and others involve more projects. And these servers can connect to computational nodes through an OBM computational packs. I don't want to explain it more, so it's complicated, but this computational node can be replaced to another one. So we not assume when we connect to a computational node that it will be permanently available for a long time. This is the main idea behind this thing. So can you go ahead, please? This computational pack that I mentioned is also a Docker-based solution. It's a very simple thing. It just contains the data, the script files, and it can contain the results. And this computation pack can be transferred from an OpenBiomaps database server, from the application server to a computational server. Yes, we can go ahead because very short time, and I would like to explain our current state with the EOSC Marketplace. So we deployed the OpenBiomaps service on the market, so we became a provider, a service provider. And this is not ready yet. We are searching, we are looking for the right path, how we can put together these things, because we have private OpenBiomaps servers as well. We have private computational servers, and now it is possible to create OpenBiomaps server. And also it's not possible yet, but we are working on to create computational servers on the EOS capacities, and we are working on to build such like server which able to use already existing EOS services as a background services. One of the most important thing now is the Jupyter. We would like to involve Jupyter somehow and put together, and we would like to keep all these connections very dynamic. I don't know, can you understand it or not? Maybe it's too complicated, but I have only one slide left, the last one. This is a here you can see the data connection life cycle that we are working on with these huge organizations in such a way that our users have almost no perception of what's going on when they performing an analysis on their data on an OpenBiomaps platform. So there are several virtual layers in this life cycle. The people use a database. They learned how they can manage their data. They start perform an analysis, which also supported, and they don't know what's happening in the background. Just got the results, and the data is go through these big infrastructures. So that's all I wanted to share. Maybe I could keep the time.
Thank you.
All right.
Thank you, Miklos and Eleonora.
Then maybe let's have a quick look at the Slido. I see not many people have posted something there. We only have one question for now, which is from Rudolf, who's asking whether there's any small compute resources that are available through the EOSC Marketplace, where users can visualize or process open data without going through an order process. I don't know whether any of our speakers can give more information about this.
Let me answer. To my knowledge, there isn't, and I tell you why. Because, for example, I know that in EGI or from EGI, we used to have one. The EGI notebooks, which is still in there, used to have an option. Well, do you share your screen now? So the EGI notebooks in the marketplace used to have an option where you could just come in, and with the existing account, you were already logged in, so nobody approved your request, and you got very minor, just really a playground. I think 1 CPU or 1 GB storage, something like that. And believe what happened. The Bitcoin miners turned up, and no matter how small the capacity was, they still hijacked some of the servers. So even we stopped doing that service without authorization. So even for the small capacity playground, there is a relatively easy and painless authorization, but it's causing a bit of delay in getting access. However, there are kind of as easy as possible and as painless as possible playgrounds available. And EGI notebooks is just one example. The other is, for example, the Praise startup, I think it's called startup allocation, that has a similar purpose, that before you get full access to big machines, you have a playground to try out your computing.
Don't know whether that answers your question, Rudolf. If not, feel free to unmute and follow up.
Okay, I was not sure whether I'm supposed to, whether I can do the discussion also. Well, the question linked to that is, of course, I mean, even if you go to Praise, you will have to make a formal request. And that means that ultimately, for the time being, there is no way with EOSC to access open data on one side and to process it lightly in a sandbox on the other side. If that means, so on the fly, which means it has to be a formal action. I'm not sure that this is attractive for the long tail of science users. Of course, you're pointing to a very delicate and very complicated issue, which is security. One can imagine all sorts of scenarios which will make it impossible, maybe, to have free access. But then again, that's a fundamental limitation then, which means that on the fly, there is no way that a user can combine data, finding data, transferring data, visualizing it, processing it, storing results. This has to be then always a very well prepared workflow. So it's not a discovery action. It has to be something which is really prepared. Correct?
I don't know all the combination of services in EOSC, but I do know that we are working towards that scenario that you can just come in, get access to a computational environment through which you can already discover open data. And with these EGI notebooks, that's what we do. So if I don't know if you, Catherine, could open that entry. But in the...
Yeah, I'm not the one sharing my screen.
Okay.
But if you want to share your screen, I think you could.
Yes. Yes, I'm sharing it. So where we are going with this one is that there is some level of compatibility between the computational environments, the applications, and the data sets that are in EOSC. And the user could come in and just combine any of these as much as possible. We are not there yet. But for example, with these notebooks, we already connect that to computational notebooks that are in OpenAir Explorer. So you can import ready-to-use calculations from other users into the notebook environment. How those notebooks link to the data and can reach the data or discover new piece of data, I'm afraid that's still up to individual notebook developers. But the ultimate goal and vision is what you described earlier, that I can come in, I can discover notebooks, and I could discover data sets as well. And then after I got into this notebooks environment, I can just pick and choose whatever is advised to be compatible, for example, or I can upload my own data and produce that cross-referencing with the existing data sets. So we are, I think we are, we are getting there, and the first elements are already visible.
Just to know whether we fully understood your question, Rudolf. Are you talking really about seeing which notebooks are already available, or more that if you have a large data set that it's set up for you to easily explore that data set?
No, let me reformulate it, but I think, I got my answer. Now, let me reformulate it nevertheless, just for better understanding. I'm not worried about the researcher who has a good understanding of what she or he wants to do, and also knows the research infrastructures capable of answering to that need.
Okay.
What I'm worried about is that EOSC will not be able to offer basic services for the long tail of science, for citizen science, for the people who are not attached to research infrastructures, who come to EOSC, discover resources and foremost open data. This is what EOSC is supposed to be about. They discover open data, and they want simply to understand what the open data is without drifting away into data catalogs of research infrastructure A, research infrastructure B, C, D, eventually the requirement to combine a bit of data to make something new out of it, without going through a nightmare of interconnecting small bits and pieces to do something with the data, which would mean that this person is exactly in the same situation as an experienced researcher. You see what I mean?
Yeah.
I mean, today, when you go to Google and you do something, you get everything. You get the data, for instance, geolocalization. Behind it, you have an infrastructure which runs and does things with data without you as a user having to request anything. It just happens. And this has to be at one point possible if we want to realize to its full extent EOSC. Today, what we have with EOSC, I suppose, is an aggregation, a collection, catalog of services which are independent, each of them being able of doing something, but which are, of course, very, very complicated to use in combination. And most of the time when it comes really to do something concrete, other than finding somebody who can offer you a piece, then it becomes really very quickly extremely complicated.
Okay, I think Marek replied to that in the comments, and I think it ties in here where he says, why not have one login for EOSC services and this way prevent Bitcoin mining? If services used are not in line with the rules, it can then be banned from access. There, I don't know, Gergely, whether you want to follow up on that. I think, are you saying, Marek, that there should be a login, one login for services?
Yeah, could I step in?
Yeah, sure.
Thank you. Sorry, because it was limiting me in number of characters I can write, so I tried to shorten it, which messed it up a little bit. Yeah, well, if I understood well, I can use different logins for the services, and this is kind of crazy. There should be really a single login web page for EOSC, and then I can do whatever I want because I will be authorized or not to do things. So this is absolutely critical for this question which was asked by Rudolf. So if I have one login and everything is linked, then it should be easy to access the services and without too much hassle.
I think, Gergely, I don't know whether you are an AAI expert, but I think I kind of need you to be on right now to answer this question.
I know some about AAI, but if someone is here from the EOSC Future AAI team, then I'm happy to give the floor to that person. If there is no one, then let me give my answer. So there are two things that needs to be balanced. One is that to have a strict control on the accounts, right? And then be restrictive in a sense that we trust this set of accounts and you have to come with those. Otherwise you are out of the game. And the other is to lower the barrier of access to EOSC, or in other words, let everybody in with whatever account they have. Okay, so these are the two balancing forces that we see for a decade now in EOSC, right? What the EOSC AI is trying to do is make everybody happy. We accept at the moment every account, I think there is somewhere probably a list. So it's all the EduGain account, which is a long federation of national accounts with very different qualities. Even in EduGain, some institutes are very strict and linking the accounts to really an identified person. I'm sure DAISY is one of those. So if somebody comes with a DAISY account, then we can be sure that that person is really an existing person, is really still working with DAISY, so we can release the resources for him or her. But at the same time in EduGain, there are identity providers who we cannot trust because there are proof that they just give out accounts, never revoking accounts, even if the researcher leaves the organization. And that's why you cannot put a single trust framework around all of these identities. So there is, inside EduGain, there is still different levels of, I think it's called assurance framework or something. I don't remember the exact term, but there are classification of how much we can trust an identity provider. And what the EOSC AI is trying to do is to use that information and to feed that back at the level of services. So then the service can decide that I trust this level of accounts, so I automatically can release, for example, resources. And I don't trust those ones, so there is a manual approval needed. But because of this multi-to-multi connectivity, it's not that simple as it sounds.
Yeah, I see your point.
Okay. But for example, referring back to Rudolph's question, so for example, in notebooks, what we are trying to build from EGIAs is to give you an integrated hub where basically you can have notebooks that you can import from OpenAir or some other sources. And we have something called a data hub space through which you can discover open data that are registered in this data hub. So if you come in as a long tail of science researcher with no affiliation to any research infrastructure, you can still get your, I think it's now 4 CPU cores with, I don't know, 10 gigabyte of space, and you can pull in and import data from the available set that we put there for you in advance. So that's where the kind of interaction between EGI and the research infrastructures come in place. Because if the research infrastructures could release their valuable and trusted data sets for us, then we could put them into this data hub immediately, making all those data available for the long tail of science through this service. But again, this requires some preparatory one-to-one discussions between infrastructures, research infrastructures to select the data sets and register them. But the framework is there. So it works. You can just go there right now.
Yeah, I think, Rudolph, it's something maybe to follow up on, because I do understand what you mean, that if you come in without an affiliation and you want to just explore what is there, it might be more complex. I don't know, because the notebooks from EGI, I think, are sort of across disciplines, but I think there are services there. Again, I don't know what the ordering process is to visualize specific data sets. I think, for instance, that there is something like that in there for Sentinel-1 satellite data through Copernicus, and I think there might be other disciplinary resources in there, but I don't really have the overview or the knowledge to tell you anything about that, but I can surely get you in touch with someone who could, to maybe give you a better idea of what is possible right now and what will be in the future. Then there's another question I want to get to. Someone asked something about use cases, and I replied to you in the Slido. So
sorry, it was me before I changed and realized that I am anonymous, Marek.
Okay.
Sorry. Yeah, well, sure, but this was a provider. This was, again, a lot of theory, and yes, but what would be absolutely lovely, and once in, I think it was EOSC Future workshop or something like that, there was a lady from Norway, and she was showing how she's using services, EOSC services. And this was absolutely the best I heard up to now. And I believe me, I was on 20+ hours of EOSC various meetings and workshops, and that was best 20 minutes.
Okay, but that's very useful input. I think that there's one question, and I do still want to get to that, which is how you could automate or replicate deployment. Is that something you could help with, Gergely?
How does the question exactly sound? Replicate deployment?
Yeah,
The question is, maybe it's from Daniele Lezzi.
Yeah, sorry. Yeah, it was referred more to the presentation of the use case. I mean, is a way that this use case can be replicated across providers, or is a static like installation deployment? Do you use something to go, for example, to scale to other providers?
So I think then
Miklos, it's a question to you.
Yes. Okay. The automatic deployment, yes, it's through the provider. So we build all of our service in Docker environment. So and it is possible to build this Docker environment services automatically through the Tosca documents and deploy in OpenStack environment these servers. Is it?
I don't know whether that helps, Daniela. Is that?
It's okay. Yeah, thanks.
Okay. Just checking. Any other questions, or shall we wrap up? If not, I think we've gotten to everything in the Slido. So then there's a few more notes from me. So as a follow-up to this session, we'll send you the recording and the slides for today. And you can also get in touch with us if you have any further questions. I'm hoping to see you again next month when we have a session on aggregators on the 3rd of May. Again, same time, same place. We'll present then the search and data aggregators that can be accessed to the EOSC Marketplace. And then the month after, in June, we have an Ask Me Anything on high performance computing. And we will announce shortly a session for September on sensitive data. What I would also like to draw your attention to is that at the end of this month, we will also be organizing EOSC provider days. So these are really sessions targeted more at providers. So I don't know whether there's many providers here, but from the 26th to the 28th of April, we'll present services and resources that can be onboarded in EOSC and how to do that. It's useful, I think, if you're just thinking of maybe onboarding something into EOSC, but also if you are currently doing so, so if you're already providing something through the marketplace, but you want an update sort of on the available features, upcoming features, and maybe how the EOSC profiles and requirements for onboarding will change. So just so that you know where to find more information, I'll post a link to that in the chat. And then I'm hoping to see you there or in another one of these sessions. And I'm also hoping that you'll still have a very lovely day. And thanks everyone for joining.